Example 3. We can estimate the annual cost of opening and operating a fuel oil-fired boiler, C sub F for fuel, in dollars per billion BTU, using the formula C of F equals 7.25 F over E, where F is the cost per gallon of fuel oil and E is the operating efficiency of the boiler. The annual cost of operating a ground source heat pump, C sub G, also in dollars per million BTU, is given by the formula C sub G equals 293 K over R, where K is the cost per kilowatt hour of electricity, R is the efficiency rating of the heat pump. Assume the following. Okay, so they've given us two different types of heating apparatuses. Okay, first one is a fuel oil fired boiler, and this is the cost function for that. And the cost function has F in it, which is cost per gallon of fuel oil, and E is the efficiency of the boiler. All right. And then the second function they've given us is the cost of a ground source heat pump. They're calling it C sub G. K is the cost per kilowatt hour, and R is the efficiency rating of the heat pump. Okay. C sub F is the cost, C sub G is the cost, and we're comparing cost between these two heating sources to figure out which one is most efficient for our neighborhood, I suppose. So what they've given us then is some information about the things so we can compare the cost. So it says fuel oil cost $2.60 per gallon. Which of the variables represents the fuel oil cost? Capital F is cost per gallon of fuel oil, and that's a dollars per gallon, right? So that is F. An existing boiler is 84% efficient. Okay, now, is that going to be E or R?
R.
Okay, they're both efficiency, right? So let's look and see. This E is efficiency of the boiler, R is efficiency of the heat pump. So again, I'm reading the words in order to know what things are. This says existing boiler is 84% efficient. Efficiency of the boiler is E. So this is E. And notice it says use 0.84 in the formula. So I'm going to put E equals 0.84. 84% efficient as a decimal is 0.84. Typically formulas don't have percents written in them. So if there's a percent given, usually you change that to a decimal. If you get a decimal answer, you want a percent, you got to modify it back to percent, move the decimal point 2 spaces to the right to make it a decimal, make it 2 to the left makes it a percent. Sorry, 2 to the left makes it a decimal, 2 to the right makes it a percent. I was looking in the wrong direction. All right, next. A new ground source heat pump would have an efficiency rating of 3.3. What letter is that? R, right? Efficiency rating of the heat pump. Efficiency rating of the heat pump is R, so this is R. And notice 3.3 is a decimal number, so that's good to go. It's not a percent. And it says, what would the cost of electricity have to be to make the two annual costs the same? So notice what they've given us. F and E are the values in this to figure out the cost of the fuel oil-fired boiler. R is this. We don't know what K equals, but that'd be the cost of the ground source heat pump. All right? They want them to be the same amount of money. They want this cost to equal that cost. So if I want C subscript F to equal C subscript G, that means that 7.25 F over E should equal 293K over R. All right. So I want, let me get some highlighters here. I want this to be the same as that, so I set this equal to that. Okay. That's got 4 variables in it, but they were nice enough over here to tell us what F equals, what E equals, and what R equals. So next I'm going to put those 3 values in. So this first equation says 7.25 times F, which is $2.60, over E, which is 0.84, equals 293 times K, we don't know yet, divided by R, which is 3.3. So I simply replace those letters within that equation. So 4 variables becomes 1 variable. Now, simplification comes down to what do you want to simplify? For me personally, maybe I want to evaluate this a little bit. Okay, I want to get an evaluation of that. So I'm going to get my calculator out, my highlighter off here, and I type in 7.25 times $2.60 equals, that's 18.85. I never divided by the 0.84, so I'm keeping it over 0.84. Over here, I'm going to keep it like it is, 293K over 3.3. Now, notice this is another technique for solving an equation having fractions in it. At this point, notice the fraction over there, 293K over 3.3, so the coefficient is a fraction. I can reciprocate, right? Multiply both sides by the reciprocal. That's a technique. Here's another technique that you've already learned this year in this class, and that's called cross multiplication. This product should equal that product, right? When two fractions are equal, you cross multiply. That is a legal process. So if I take this product here, if I do the blue product, 0.84 times 293, that gets me 246.12. What? What?
Oh, never mind.
Are you sure?
I did the other one first.
Okay, 246.12K. And then when I do the yellow highlight, 18.85 times 3.3, that comes out to 62.205. What I was trying to avoid here was if I divided this, 18.85 by 0.84, when you start dividing, sometimes you get these decimals and all of a sudden you're going to start rounding. So I was trying to avoid all the rounding errors. So I know when I multiply decimals, I get a terminating decimal and everything else was terminating. So when I would cross multiply, everything in this is exactly accurate to the last decimal place. So now to get what K equals, K is being multiplied by this number 246.12, so I'm going to divide by 246.12. And 62.205 divided by 246.12 comes out to 0.2527425646. My calculations are done there. K equals that. Okay. Let's look back at what K represents. K is the cost per kilowatt hour. Okay. Cost, since the other cost was in dollars per gallon, this should be $1 per gallon or dollars per kilowatt hour. All right. 0.25 is a quarter of a dollar, better known as 25 cents, right? So the cost that gets them equal would be rounded to the nearest cent, 25 cents per kilowatt hour. I did round that so it won't be exactly equal, but it'd be pretty close. We wanted to test that out real quick with a calculator. If I do this is the cost of the fuel pump here, all the numbers are known, so 7.25 times 2.60 divided by 0.84, 22.44. All right, that's dollars per billion BTU. If I take my answer here, 0.25 times 293 divided by 3.3,
You can grab me one.
comes out to 22 to $20. So it's off by about 25 cents there. But again, it has to do with rounding errors. So the fact they came out about the same cost per billion BTUs, that means that will be the right answer.